So let's start learning something about K-way merge. So in the previous program, we learned what is consequential processing, and then we took just two lists and then tried to uh, find the match between all the lists. Now here in K-way merge, we consider K is equal to 4 and we have 4 different lists of names that are currently sorted. So this is the list of lists of lists. So we have a list of names, okay, and that are sorted. For simplicity's sake, we'll just consider the first letter of the name. So now how does the K-way merge work? So let's take this example of lists of names. Now what we need? So we need a list which has a list of all the names that are sorted, right? So again the same thing goes if we actually read each of these from 4 different files, okay, into the array, and then we're going to sort it. So we're going to put that in actually a bigger list. Okay, so this is 1.txt, 2.txt, 3.txt and 4.txt, and in each of these files we have the names. So we're going to read each one of those and then put them in the list and sort it. Now our basic list is ready with all the names and which are sorted. Now how does K-way merge work? Now initially we need, even before we start, we need certain things. We need to know how many names are there in each of these lists, right? So we know that there are 4 names in the first list, 3 names in the second, 4 names again in the third list, and 3 names in fourth list. Now, so when we start actually processing it, we need to know whether we have seen all the names, right, in a list. Have we considered all the names? Have we processed all the names? Okay, if we have still not processed one of the names also, available will be 1. So if are there any names available still that are not processed? If it is yes, then the avail list will contain 1. So initially the avail list of each of these lists is 1, which means to say we have not yet processed any of the names and still there are names to be processed. Okay, so let's start. So we'll consider the first name of the first list and consider him to be the smallest. Okay, so now smallest is A, that is first name in the first list. So now what are we going to do? We're going to check whether the next list is still available. Is it still available? Yes, it is still available. Now from here, what are we going to do? We're going to compare this name with all the other names in the list of in the future further lists. So we're going to compare that with B. So we know A is still small, so we're going to advance to the next list and compare that with this. It is still the same, A, and then we're going to say again E. Still A is small. So now at the end of the list, we do not have any other list to compare. So now what happens, right? A is the smallest, so I'm going to write that in the merge list. A is smallest, right? And then I'm going to say I'm going to reduce the count here, right? I'm going to reduce the count because in the next iteration I'm not supposed to talk to this guy. So this name is processed, and in this list, in the first list, now I have only 3, so I'm going to change that count. Next I'm going to start again with this the next name, right? So B is the next element that we're going to consider. We'll consider B as the next small element, so we're going to compare that with this B. It's the same, so we'll go ahead. Now we found a new small, right? When we compare B with A, we found that A is supposed to be the small, so we found A. And then next we're going to compare it with the next element in the next array. It is the smallest, but then we know that there is already a here, so we're not going to write here, but then reduce the count here. So instead of 4 we say 3. So now this A is again processed, so this is not considered again. But here we are going to stay here, and then we are supposed to continue again. We are going to start off, check whether this list is still available. Yes, it is still available, so B is our next smallest element. So again go and compare. So B, same thing. C is still bigger, E is still bigger, so B is our next element. So we are going to reduce this further by 2. So now these two are processed, right? So two of these are processed, done. So next I'm going to start off again from the beginning. So I'll consider C as my new small element. I'm going to compare it with all the other names in the next list. So here now we're going to compare that with B. Now I found that B is the next small element. So I'm going to compare again with C, no, E, no. So again B, but B is already there, right? So I'm going to reduce the count here, right? So B is already processed. Now the next small again. So here because I'm still not started, we still C is unprocessed, so C is still there. So whether the next list is available, yes, it is there. C, yes, E is greater, so go to the next list. C, same thing. So again come here, right? So E, so C is the small one, so I write here. So I am going to process this, consider that this is visited, and reduce the count here by 1. So now I have only one element left in the first list, that is unprocessed, right? So the next thing, in the next iteration I'll consider D as the smallest element. So now when I compare D with E, D is smaller. C, now in this list I get C, so I'll consider this as the new smallest element, C, right? And then I'll compare it with E here. I know that C is the one, but C is already there here, so I'm going to consider that this is processed and reduce the count here from 3 to 2, right? So in the next iteration I'm going to start off again with D. D is my smallest element, E, D here again, E. So we know that D is the smallest element, and now in the first list you now observe that all the elements are processed. So the count is 0 and available becomes 0. Now all the elements in the first list are now processed. So that now when available for first list is 0, we are no more processing the first list. So now our first list becomes the second list, right? So now we are supposed to start with the second list and consider E as the next smallest element and compare it with D. Now we got D as the smallest element, right? And then compare it with E. Now D is already there, so I'll consider that D is processed and reduce this count to 1. So now in second list I have only one element. Now again I'll not start with list 1, I'll start with list 2, second name. So I'll consider E as the smallest element. I'll compare it with E again. So E, I got it, right? So I'll reduce the count to 1. I'll consider this as processed, right? Now I'll again start with the second list. G is the next element. So EG is the smallest. Now I'm going to compare it with I. G is the smallest. E. Now I got E as the smallest, but in the list I already have G. So I'm going to reduce the count to 2 for this list. I'm going to consider this as processed. So again I'm going to start with G, right? G is the okay. So there's a small problem. E was over. There is this F. So even before we write G here, so even before we yeah, so there's 2. When I compare with when I had G as a thing, I have F here. right? So when I compare it here, f is now the smallest one, so I'm going to write f here. I'll consider this both as processed. So now the the count in this particular list is just 1. Now I'm going to start off again from G. G is the smallest, G is again here, so I'll write G here, right? And consider this as processed. So the moment I consider this as processed, the count of this also becomes 0, so avail also becomes 0. So second list also is completely processed. Now whenever I start, now I start only from the third list. I is the element that I have. I is compared with G. G is then small, but G is already there here, so I'm going to process this, and I say 0, right? And then avail of this is also 0. Now there is only one list with available and list. So this may have as many number of elements that it has, but there is nothing to get compared. So what we're going to do is, how many lists are there here, how many names are there in this list, we're simply going to copy. So there is no other comparison mechanisms. Now we got the merge list with us. So this is how KV merge actually works. So please remember, we have lists of lists, we have something called as count, and we have something called as avail list. Right? The moment the avail list becomes 0, we know that all the elements in the array are processed, and the moment count becomes 0, avail also becomes 0. This is KV merge.
So after the board discussion, now we would have understood what KV merge is all about and how we go ahead doing it. So now here in this case, what you are supposed to do is to write a C++ program to read k lists of names and merge them using KV merge algorithm with k is equal to 8. So for simplicity reasons, we consider k as 4. However, the code is ready for all the 8 files as well. So when the list k is equal to 8, we can still run it. Now before executing the program, we need to have 8 files, or if k is equal to 4, we need to have 4 files. And then what are we supposed to do? So these are the things that we do. Same thing as the previous program. Read all the k lists from k files and store these lists in a 2D array, like lists of lists. So this is read file, and then we are supposed to sort all the k lists using sort lists, and then we are supposed to call the KV merge, the logic, which logic is extended version of merge sort. So what we're doing here is to merge all the k lists. We'll start seeing the listing. So this is, we have a class called sequential. So we have the list of lists. So we have 8 capacity of 8 lists with 50 names each, and then we have something called output list, where we are going to write all the merge names, right? And then we have something called count 1 and count 2. So we'll see why we are going to use this. So as usual, so we're going to read the files, we're going to sort them, and then finally call KV merge. So in the main, so what are we going to do? In the main function, we are going to repeat this reading the file and sorting the lists for 4 times. So we're going to consider k as 4 here. Now so initially our count will have 0 because we do not have any names in the lists. Once the list gets populated, your count array will also get populated accordingly. So as many number of names are there in each of these. So count of 0 is number of names that are there in the first list, right? Like that. So we'll see what happens when we call read file 1. So when we call read file of 0 1, the first list is opened and it is parsed and read and then populated here. So list of I of count of I plus plus is equal to name means what? So we're going to populate the first list, okay, with all the names that we read here, and every time we need a name, we're going to increment this value here, right? So at the end of the file we will get to know how many number of names are there in the first file. So in the lists of lists we are reading the first list, and in the first list we have these many number of names. So this is something which we are going to repeat for all the 4 files. So we're going to open the file, we're going to read every line and then put that in the list of lists, and when we do that we are going to get how many number of names are there in each of these lists. So count 1 is all about how many number of names are there in each of these files. Right, so this is about reading the file. Exactly after reading the file we are supposed to sort the file or the list, not the file, sorry, the list. So sorting is very simple. We have already said that we are going to use the bubble sort technique. Temp is equal to I is equal to j is equal to temp. So we are going to sort that. So once the lists are sorted, then we are going to call the KV merge. So KV merge we need few pointers and as in the markers. So we'll have all these start list, count 3, start, and then avail list, avail, and all that. So as we saw in the board presentation, we'll have something called as avail list. So this is going to tell you whether the list is still having some unprocessed names. So if the moment avail of some list becomes 0, it means that we have processed all the names that are there in that. And this is the remaining count, or the number of names that we have already processed. Okay, so this will tell if the list still has some names. This is going to tell you how many names are processed already, right? So this is going to tell you that. So avail is going to tell if still there are some names that are unprocessed. Count 2 will tell you how many names are already processed, right? So now this is the main logic of KV merge. So we are going to get into this loop every time there is at least there are at least two lists that are unprocessed. Okay, unprocessed, that have unprocessed names. So because if there is only one list, there is nothing to compare, right? So if avail list is greater than 1, that is at least 2 files lists are there which has got unprocessed names, then we are going to start. So this is what, if the first list that we are going to consider is if it is not available, if the list that we are going to touch first is not available, then go to the next list. Okay, start will be now incremented, go to the next list. Initially we started off with the first list is start is equal to 0. So this is where it is. Start is equal to 0 means the first list. Okay, if you remember the board discussion, we started off with the first list, right? So first list, first name. So if the first list, first name itself is unprocessed, processed already and it is not available, then go to the next list, right? That's what it means. So what are we going to do now? If this is not the case, if it is still available, then our start becomes our S list becomes the start. So start list becomes the first list, or the 0. Now we are going to consider the smallest element as the first name in the first list. Okay, and then we are going to start this comparison, right? We are going to compare the smallest element in the first list, the first name in the first list, with all the other lists. So start plus 1, right? I is the start list, first list. Start plus 1 to 4 is the next set of lists that are there. So if it is not available, if the next list is not available, go to the next list, continue in this loop, go to the next list. Otherwise, just check whether the name that is there in the second list is small. So if that is small, then you are going to have a new small and you are going to have a new I. I now becomes your start list now becomes the I. So I plus plus. You're going to continue further from the next set of lists that are there. Okay, and then you continue this until you reach the last list. So once you do this, the moment you come out of this, you will have the smallest element with you, having compared, and then in that particular list you are supposed to increment the value, okay, to 1, increment that value, which means to say in that particular list I have one processed element. I have already processed one element, right? From whichever list you got this small, you're going to simply increment that. So now, so this is something which you're going to repeat, right? And then if count of 2 of S list is equal to count of 1 of S list, which means to say if you have processed all the names that are there in the list, and if that is equal to the total number of names that are there in the list, then avail list becomes 0, right? So from the avail list we are supposed to reduce one list. Avail list initially was 4. Now if one of the list becomes completely processed, if that particular list contains no names that are unprocessed, then you are supposed to reduce the count of avail list. And then if that is not the case, then out list. What are we supposed to do with that small element that we found? That is the element that we are supposed to put in the out list. So like this, every name will come and sit in the out list, right, at the end of the loop. So at the end of the loop, every iteration of the loop, one of the smallest element will come and sit in the out list. That's what we saw in the board discussion, right? So this is something which we are going to repeat until there are, all the lists become unavailable and there is only one. Now if there is only one list that is still pending and it still has names, what are we going to do with that? So what are we going to do with that? There is nothing to compare, so we are simply going to copy all those values into the out lists. Okay, so that's exactly what we are going to do. So this is what is happening here. So for that particular list that is still unprocessed, what are we going to do? Start with some value where it is unprocessed, go on till the end of the list and simply copy that to this particular file, this particular list. Simply go ahead and copy it. That's it. So for I is equal to j of count is equal to that is count 2 of I, j is less than count 1 of j plus plus, which means to say wherever you were in this list, from there till the end of the list, please put all those things in out list. So that's exactly what we are going to do, because there is nothing else to compare, right? So once we do this, now we have all the elements that are ready with us, right? So we're going to simply display all those things as the merged list. So this is what is your K-way merge. Now we will see the demonstration. Okay, so let's run this program. So even before we run, we should know that we should have 4 files with us with different names. So let's see what is there in each of these. n1.txt, so we have few names, and in the next list also we have few names. You should know that there is some kind of overlap between each of these files, because to test whether it is really working, we need to know that there should be some kind of overlapping. And then finally when we get the merge list, we should know that we have got finally the merge list removing all the overlapping, right? So if there are some repetitions, it should not appear in the final merge list, right? So these are the four lists that we have. Now we're going to run the program fs8. So finally we got the merge list. So these are the merge lists that we have. Now when you compare it with all the names that we have here, it looks like that it has done the job, right? So we have got the final merged lists. Thank you.